When you look at an airplane, one detail almost everyone recognizes is its nose. Whether it's a giant passenger jet, a military aircraft, or even a small private plane, the front always seems to have a smooth, rounded shape. It's so common that most people never stop to ask why. After all, if planes are designed for speed, wouldn't a sharp, pointy nose cut through the air better? The answer turns out to involve aerodynamics, engineering, and even the equipment hidden inside the aircraft. The shape that seems so ordinary today is actually the result of decades of experimentation and practical design. So why are aircraft noses rounded instead of pointed? That's exactly what we're exploring right here on History of Simple Things. Although we often think of air as empty space, it behaves more like a fluid. As an airplane moves forward, it must push countless molecules out of the way. This creates resistance, known as drag. Engineers have always tried to reduce drag because less resistance means greater efficiency, lower fuel consumption, and better performance. At first glance, a pointed nose might seem like the obvious solution. After all, many rockets and supersonic jets have sharp fronts. But for most aircraft, especially passenger airplanes, speed is far below the speed of sound. At these subsonic speeds, air flows smoothly around the aircraft, and a rounded nose actually allows that flow to remain stable and attached to the body. This reduces turbulence and minimizes unnecessary drag. In other words, for the speeds most airplanes travel, being rounded is more efficient than being needle-shaped. In the early days of aviation, engineers did not have powerful computers to simulate airflow. They relied heavily on wind tunnels and real-world testing. Over time, they discovered that certain shapes consistently produced better results. Designers found that a gently curved front allowed air to spread evenly around the fuselage. Sharp corners or abrupt angles caused the airflow to separate, creating turbulence and increasing drag. The smooth, rounded shape proved to be both efficient and stable, so it gradually became the standard. By the middle of the 20th century, aircraft manufacturers had gathered enough evidence to know that rounded noses offered the best balance between aerodynamic performance and practicality for most airplanes. People often compare airplanes to arrows or bullets and assume that sharper means faster. But speed changes everything. Commercial airliners usually cruise at around 900 kilometers or 560 miles per hour. This is fast, but still below the speed of sound. At these speeds, a rounded front creates less resistance than many people expect. Things become different when aircraft approach or exceed supersonic speeds. The famous Concorde, for example, had a long, pointed nose. Fighter jets designed for extremely high speeds often have similar shapes. These designs help manage shock waves that form when approaching the speed of sound. But most airplanes never operate in that range. Since passenger aircraft spend nearly all their time at subsonic speeds, there is little advantage in making their noses sharp. In fact, doing so would often make them less efficient. The nose of an aircraft isn't just empty space. It contains some of the plane's most important systems. One major component hidden behind the nose is the weather radar. Pilots rely on this radar to detect storms, heavy rain, and dangerous weather conditions ahead. Radar equipment works best when enclosed behind a smooth covering called a radome. This structure allows radio waves to pass through while protecting sensitive electronics. The rounded shape provides enough room for these systems while maintaining aerodynamic efficiency. If the nose were extremely narrow and pointed, there would be far less space for radar equipment and maintenance access. Nature often inspires engineering, and birds provide a good example. Most birds have rounded heads and smoothly curved bodies rather than extremely pointed beaks. Their shape helps airflow naturally around them while maintaining stability. Aircraft designers don't directly copy birds, but they face similar challenges. Both birds and airplanes need to move efficiently through the atmosphere while maintaining balance and control. The rounded nose contributes to that smooth airflow, helping the aircraft remain predictable and stable during flight. Nature had already arrived at a solution long before humans began building airplanes. A rounded front also offers structural advantages. Curved surfaces distribute stress more evenly than sharp points. This helps the aircraft withstand pressure changes, vibrations, and the forces encountered during takeoff, turbulence, and landing. Sharp shapes can create areas where stress becomes concentrated. Over time, these concentrations can weaken structures. Rounded designs spread loads more effectively, making them stronger and more durable. Engineers are always balancing weight, strength, and efficiency. A smooth curved nose provides a practical compromise that satisfies all three requirements. So why are aircraft noses rounded? The answer isn't because engineers wanted airplanes to look sleek or attractive. It's because rounded shapes work best for the speeds most airplanes fly. They help airflow smoothly, reduce drag, provide room for vital equipment, and create stronger structures. Sometimes the most familiar features around us exist not because they're flashy or complicated, but because they represent the best solution engineers have discovered. And every time you see an airplane preparing for takeoff, that smooth rounded nose is quietly proving that simple designs often hide remarkable science. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.